Hi everyone, welcome back to our video on hypothesis testing, and we are going to look through some of the questions in our lecture review exercise. And without further ado, we have already looked at review exercise 2. So without further ado, let's start off with review exercise 1 and let's complete the rest of the questions over here. Okay, so let us analyze the question. So we have lengths of X of metal bars produced by a particular plant and so on, right? Okay, so let us highlight some important things as we read along. One important one over here would be normally distributed. Okay, standard deviation 12 cm. Claims that the mean length of the bars is 420 cm. To test this, sample of 100 bars. The results summarized like this in cm. And we're going to test the production manager's claim at the 4% significance level. Okay, so let's mark out over here, normally distributed, very nice. Standard deviation refers to our population standard deviation because they are talking about this in general. So this is small sigma. Okay, mean length of the bars is 420. So this refers to the population mean length of the bar. And this one is actually our mu. Mu is 420. Okay, we have a sample of 100 bars, so sample size n, and this sigma x over here is from the sample, and this one over here, right, will allow us to calculate our sample mean, which is our x bar. Okay, and x bar would be sum of x over n, okay, in which we will use this later. Okay, so without further ado, let us kickstart the whole process. Step 1, declaring our random variable. Okay, random variable over here. Okay, so declaring x to be the random variable and mu as the mean of x. Okay, so step 2, we are going to locate our null and alternative hypothesis. So over here, right, now claim that the mean length of the bar is 420 cm, right? So this one over here, right, because we have our mu to be equals to 420 cm. So usually for the equal sign, right, we will take this as our null hypothesis, right, in our syllabus. Okay, so there's no mention of anything else in this and this one over here is the production manager's claim. Okay, now once again, right, in this question there's no mention about like whether is it like did they say like is it more than or less than, did anyone claim more than or less than kind of thing. So there's no one saying this, right? So the opposite of equal, right, is actually not equal. So this one, right, the alternative hypothesis would be mu not equals to 420. Okay, so this is the one that is opposite the production manager's claim. So this is also another inequality, meaning not equal. Okay, so this is our step 2. Okay, step 3, we will need to declare our test statistic. Okay, so our test statistic, right, is following our z-test because this is normally distributed. Okay, so we will say that under h naught, or if, or assuming that h naught is true, we are testing for sample mean. So we are looking at the distribution of x bar following a normal distribution of normal distribution. We need mean and variance. So the mean is the mean given 420. Okay, assuming that h naught is true, so we will take this mean, okay, to be in our distribution. Then the variance over here will be standard deviation 12 square divided by n, because this is sampling, right, distribution of the sample mean, so 12 square over n, 100. Okay, so now then the optional one, which we will standardize, right, would be z equals to x bar minus 420 over the standard deviation of this. So 12 square over 100 divided by square root of this. Okay, so then yeah, so this will follow, this is a random variable, follow a normal distribution of 0 and 1 because we standardize it to the standard normal distribution. Okay, so far this is our setup. Okay, one last thing to set up over here would be to okay, look at the test and the significance level. So we're going to take okay, so this one, right, based on this over here, we're going to take a two-tail test, because not equal, it can be not equal on either side, right? Not necessarily more than, it can be on the other, it can be less than, right? So we will need to look at a two-tail test. Okay, so taking a two-tail test at the 4% significance level, we will see that the, okay, let's set up the graph as well. Okay, so so setting up this graph over here would look something like this, right? Okay, so I will need to look at the values of the x bar, and I want you to also compare with the values of the z values. Okay, so x bar, the mean is 420, so this is symmetrical about the mean. For the z value, it will be 0. Corresponding 0 value will be 0, because the mean would be at 0. Okay, so I will mark out the area for our 4% significance level on both tails. Okay, so these two areas over here, right? So now, so for the p-value method, this one over here would be 4% divided by 2, so I have 2% here, and I have another 2% over here. Okay, so this is the to set up for the p-value method, right? Now, then to set up for the critical value methods, I will need to first identify the critical region, right? So for the critical region, right, so for the method 2 of using the z-score, we will reject h naught when, okay, so now how do I set this up, right? Because I will need to look for what is this score over here and what is this score over here, right? So given the probability I want to look for the value, right, this is actually a inverse normal problem, right? It's a reverse problem for our normal distribution, right? Given the probability, find the data, right? So we'll need to use the inverse normal for this. Okay, so looking at the calculator, right, over here, now there's many ways to do this. I would look at the right, 2% on the right, and it will give me this value. I can also look at 2% on the left, right, and it will give me this value over here. Alternatively, if I were to look at the middle piece, so because this is 4%, right, in the middle I have 0.96, right, 96%. So if I were to put 96% over here, right, and if I were to choose center, right, I can also find these two values as well, because it gives me 96% in the middle. Okay, so I'll be doing this, and I will, especially for two-tail test lah, right, and I will get my values like this. Oops, sorry, like this. Okay, so these are my values, right? So my values are 2.054. Okay, so this means to say that the z value, right, this one over here is negative 2.054. This one over here is 2.054. Okay, so this is the critical region, okay, for the z-score. Okay, so this one is for the z-score, right? So I will reject h naught when z is less than negative 0.2, sorry, negative 2.054, or when z is more than 2.054. Okay, so this is for the z value the critical value method, but using the z value, right? Now, if I am looking at the raw data, or if I'm looking at the context, right? So if I were to just take a look at the values of the sample mean, right? So I would also need to find out what is this value. It's the same thing, it's the same process, just that I'm looking for the sample mean value over here, right? So over here, if I were to look at inverse normal, sorry, if I were to look at inverse normal, same, I'm going to do the 96% over here, right? But I will base this off the distribution over here. So the mean, population mean 420, the standard deviation over here, I will follow this one over here. Okay, standard deviation would be 12 square divided by 100 and square root like that. Okay, center. Okay, then I'll paste. Okay, so my numbers over here, okay, so this one over here, right, would give me 417. Okay, sorry, 417.54. Okay, and on the right over here is 422.46. Okay, so something like that. Okay, okay, so let me bring this closer inside. Okay, so this is what we see for, okay, so this is us setting up for the critical region. Okay, so okay, uh, okay, so same thing for the sample mean value, right? We drag h naught when x bar is less than 4.417.54, or x bar is greater than 422.46. Okay, so this is the critical region that we will outline. Okay, so now after setting up this part already, okay, now I want to look at where is my sample mean. Okay, I want to look at where's my sample mean. So I will go on and furnish you with the 3 different methods. Okay, now so for clarity purpose, let me do for method 2 and 3 first. Then I will leave the last for my favorite method, which is method 1. Okay, now so for the critical value method over here. Okay, so once again, all this, right, we use inverse normal, okay, to find our critical region if you are doing the critical value method, right? So for method 2, right, and 3, what do we need to do is we need to figure out what is our sample mean. So from the sample, x bar would be equals to, okay, x bar over here, this one, 42300 divided by 100. Okay, so it will be 42300 divided by 100. So this is equals to 423. Okay, so same thing over here for method 3, right? So from sample, okay, x bar is equals to 42300 over 100. So this one is 423. Okay, in the same way, we can repeat this also for method 1. Okay, so it's the same thing for method 1. Okay, now looking at this situation over here, right? Okay, so where is 423? 423, right, is actually over here, right? So 423 is actually over here, right? So because of this, right, we can see that directly from the sample mean value, right, this 423, right, is actually greater than 422.46, which is greater than the critical value. Okay, so means that this 423, right, lies in this rejection zone, and it tells me that 423 is actually significantly far away enough from the population mean 420. Okay, something like that. Can so this is the first, so this is method 3. Now for method 2, right, how do I get the z value? I can do my own calculation, or I can go to my statistics, I go to my test, go to z test, okay, input my data over here, 420. Okay, the sigma is the original sigma, which is just 12. Okay, in the question, then they'll do all the back end work for us. Okay, x bar over here 423, which is what we've calculated. N is 100 for the back end work. Now this is a two-tailed test, so I'm going to put not equal. Then I'm going to calculate over here, right? So over here, right, I will look at the z value. This z value over here is, okay, from GC. Now my z calculated over here is actually 2.5. So where is actually 2.5? 2.5 is actually over here, 2.5. Okay, and this 2.5, right, is greater than 2.054. So greater than the critical region 2.054. Okay, and because of this, we can reject lah, the null hypothesis. Okay, so this is the method 3, method 2. Now, last but not least, method 1 is just the p-value. Same sequence, right? But straight away, we can get the p-value over here. So this p-value over here is equals to 0.0124. Right? Now, but we need to compare this p-value with the significance level, the probability over here. So this probability is less than the probability 0.04. Okay? So because of this, right, the conclusion that we can write, okay, the conclusion that we can write over here is we can reject H naught. Okay, so because of this, right, okay, the decision over here is we need to reject H naught because it falls in the rejection region. Okay, and step number 7, which is to state the conclusion, there would be, because we need to reject, right, so it will be significantly far enough so that we say that there's sufficient evidence at the significance level to conclude that the manager's claim and so on and so forth. Okay, so yeah, okay, so this over here will be our conclusion based on the context. Okay, so now how do we do this is that because this is not true, this is true, we say that the manager's claim is not supported lah, or not valid. Okay, something like that. Okay, so now back to this drawing board over here, right? There's something that I need to discuss about the p-value method. So hopefully, I think by now you should be clearer on the critical value method. And it's not that we have to use this because technically we need to write a bit more. We need to write this and this, or we need to write this and this. It's really a little bit more, right? But for p-value method, right, we just need to look at the probability, right? This probability over here is 0. Okay, so this probability over here, right, it refers to, okay, this p-value over here, right, it refers to the probability where, okay, because first we need to look at 423, at this 423, right, and 423 is on the right hand side of 420, right, so this p-value over here is where the x bar is greater than 420, the probability where x bar is greater than 423. But because this is only one side of the picture, right, and we are taking a two-tailed test, right, and because of that, right, I will need to take this probability times 2. Okay, so this probability over here, right, is actually times 2 of the probability where x bar is greater than 423. Okay, so for a two-tailed test, the probability that we shade over here, right, we need to times 2. Okay, or the calculator will do it for you, and then you just compare it directly. Okay, or you just need to be aware that the calculated value over here refers to this one times 2. Okay, so this is what the question is asking for. So meaning, right, the other side over here, the probability that we calculated, the p-value over here, also refers to this area shaded. Okay, so this is something that I want to bring up for question 1 lah, for with regards to a two-tailed test. Then for part B, we need to illustrate the z-calculate and the p-value, right? So the p-value is actually over here. Okay, the p-value is actually over here. This purple color part. The z-value is actually over here, 2.5 and this. Okay, so that will be for question 1. Okay, so on this note, right, I will also show you very quickly on how do I get the p-value method if you don't use the statistics z-test. Okay, so I will just make use of the normal CDF, right, and I'll key in the data as such. Okay, so this is what I'm keying in. Okay, the lower is 423 because I'm at 423 is here, right? I'm looking for this side, right? 423 is actually on the right hand side of 420, so I'm looking for the lower is 423, upper is infinity. I'm going to paste this, right, and I will see that actually this is 0.06, right? So the thing is the p-value is actually this one times 2, right? And then you can see that this is actually tallying with our p-value 0.0124. Okay, so once again, the p-value for a two-tailed test, right, is that we'll need to take this and multiply by 2. Okay, it's just for presentation's sake, but the ultimate answer, the ultimate use of this is to tell us that actually 423 is in the rejection region and we can reject our null hypothesis. Okay, so with this, let us go on to question number 3. Okay, question number 3, inspector of items claims that he takes on average, okay, 21.75 seconds to check each item. Okay, the time x seconds that the inspector takes to check each of 50 randomly chosen items. So this over here is our sample, and given this one over here, given this sample thing over here. Okay, so like let's not dissect everything first. Let's look at unbiased estimate, or maybe let's dissect. Okay, so over here, right, on average 21.75. So this one refers to the population average. Okay, population on average, right? Okay, this refers to the population, right? And this one over here is actually our mu. Okay, they never give us out the standard deviation. So later, the first part A, right, is to make use of the unbiased estimate for our standard deviation. Okay, so let's do part A first. Okay, so unbiased estimate of population mean. Okay, the sigma over here is that population mean is mu. We want to estimate, so it's mu hat. And in our syllabus, mu hat is equals to x bar, the sample mean. And what is the sample mean? 1107 divided by 50. Right, so this gives us a value of 22.14. Okay, now then unbiased estimate of the population variance. Okay, so this one, right, is they have a notation s square. Okay, and s square, we have a formula to follow. For this one, right, we are given these two quantities, so we can make use of the formula in our MF27. Okay, to put in 1 over 49 and put in the values over there. Okay, and this one will give us a number 1.7018 sorry, 7014826, roughly 1.70 to 3 significant figures. Okay, so this would be for part A. Okay, so part A done. Part B. So now let's do the carry out the test. So once again, this is a forward question. We have the setup over here, and we are going to test forward. Okay, so once again, you can refer to the question before question 1, the part over there to refer to the steps. And now I won't write down 1 to 7. I'll just write out I will just tell you, and I'll just show you how is it presented normally. Okay, so step 1, declare random variable and population mean mu. Okay, so there we have it. Step 2, null and alternative hypothesis. So the claim that on average with the mu population mean is 21.75. So this equal, right, would be our null hypothesis. So H naught would be mu taking the value of 21.75, and this one over here, right, is the inspector's claim. Okay, so later in the conclusion, I'll make reference with this. Then for H1, the null alternative hypothesis. Now there's no mention in the question on whether is it greater than or less than, or anything that increase or decrease, right? So the opposite of equal is actually not equal to 21.75, and based on this alternative hypothesis, we will need to take a two-tailed test later. Okay, next step, we are going to look at the test statistic. Okay, so this one over here, let's set up our test statistic. Okay, so this is, okay, so the thing is that for this question, right, there's no mention of our of a normal distribution, right? So under H naught, right, there's no mention of a normal distribution, right? So this one over here, not normal. And because this is not normal, right, we need to check for this sample size. Sample size is greater than 30, and because of this, right, n is greater than 30, we can use CLT to get our x bar to be normally distributed. Okay, can so the idea is this. Okay, so under H naught, so since okay, n is equals to 50 and 50 is greater than 30, right? By the central limit theorem, okay, by the central limit theorem, our x bar will follow a normal distribution of, okay, so we, once again, normal distribution, we need mean and variance. So under H naught, or assuming that H naught is correct, this is our population mean. So we need the mean 21.75. So we'll follow this from the null hypothesis, right, under H naught. And for the, they never give us variance or standard deviation, but we can make use of um, the unbiased estimate, so that we can use this to as an estimate for the population variance, right? So over here, we will make use of 1.701486. Okay, so this is the unbiased estimate of the variance divided by our n, oh sorry, n is 50. So divided by 50. Okay, okay, and it will be normal approximately. Okay, so something like that. Now, so the optional one to standardize, if we want the z, we have this quantity over here following a normal distribution of 0 and 1 after standardizing. Okay, so this is our test statistic, okay, for the z test, okay, using the z distribution. Okay, so now we can take, because based on the alternative hypothesis, we can take a two-tailed test at 4% significance level. Okay, so now let me split this up to the three approaches, right? P-value method, the critical value method, and the two critical value method. Okay, so I'd like to clarify that this graph is actually optional. Okay, so technically you don't need to draw a graph, you can just continue to write using the methods. The graph is here for actually for me to help you visualize what's going on. Okay, so once again, let's set up this graph. This graph over here, right? Population mean, okay, 21.75. So we have our population mean over here. Okay, so there we have it. Then for the 4% significance level, I will need to, this is a two-tail test, right? So I need to mark out both tails. Okay, now, so for the p-value method, I'm going to look at the probability. So 4%, right, on each side will be 0.02. This one over here will also be 0.02. Okay, so now let me, so for the p-value method, I can do this straight away. Let me kickstart the p-value method process right away. Okay, so to my calculator, let's go to statistics, go to test, z-test. Okay, so let's key in our statistics over here. The mu not 21.75. The sigma, which is the original sigma, is actually, this is the variance, right? So we are going to look at the standard deviation. So this one, be very careful. So 1.7014826. Okay. X bar that we've calculated over here. Oh, we haven't calculated our X bar yet. Oh wait, we have calculated our X bar, which is actually 22.14. Okay, so now, so from here, from sample, okay, X bar is equals to 22.14. Okay, so means to say that it will be on the left hand side, right? So 22.14, let me key this to the calculator. The n over here is 50. Okay, n is 50. Okay, and we're looking for a two-tailed test, and let's calculate. Okay, so p value over here, right, you can see over here is actually 0.03. So from GC, okay, our p value over here is 0.0345, and this one is actually less than 0.04. Okay, so this tells me that 22.14, sorry, it's on this side, 22.14. So this tells me that this area that we are shading over here, okay, this area that we're shading over here and this area that we're shading over here, right? So the total area, right, is actually 0.03, which is less than 0.04. So this tells me that my 22.14 is actually over here in the rejection region. Okay, and because of that, the conclusion is we need to reject our null hypothesis H naught. Okay, and there is sufficient evidence to reject the claim, to reject the null hypothesis. Okay, so there we have it, our conclusion over here. Okay, now let's take a look at the second one, which is our critical value method for the z-score. So I will need to establish my critical region first, okay, to make things easier, or to like make things clearer. So the critical region, right, is we will need to reject our null hypothesis when, okay, the z-score is outside of this, right? Okay, so meaning to say that because this is 2%, this is 2%, right? The one in the middle is actually 96%. Okay, so I'm going to do inverse normal but for 96%. So these are the specifics that I'm going to put in, right? 96%, 0, 1, center and paste. Okay, so my values are negative 2.537 and so on. Okay, so I'm going to reject this when z is less than negative 2.05 or z is greater than 2.053. Okay, maybe 4. Okay, round up 4. So this is the critical region. Now from sample, okay, x bar is 22.14. Then from GC, okay, if we were to look at the statistics, right, and the test in the statistics, right, just now the results that we got, now this one, the z is 2.11. Okay, so the z-score, the z calculated over here is actually 2.11. Okay, so what does this mean, right? This means that for the z, okay, so this one over here is x bar, this one now is z, right? The mean is 0. Critical region, right, this is 2.054, negative 2.054. Just so happen that we calculated this is 2.11. So 2.11, right, is actually over here. Okay, and this 2.11 is greater than 2.054. And because of that, we need to reject our H naught. Okay, now then for the third method, okay, same thing, we need to establish our critical region. Okay, for the very third method over here. Okay, so same thing, we will need to reject our null hypothesis when, okay, so this one over here, right, we need to refer to inverse normal. Okay, so the one that I'm going to put in here is same thing, 96% in the middle, 4% outside, right? So 96% in the middle at the center. Okay, the mu over here, I'm going to put in all this. Okay, so putting this one carefully, right? I'm going to find out the values. So the value over here is going to be 21.75, right? So on the left it will be 21.371. This one over here would be 22.129. Okay, so I'm going to reject H naught when x bar. Okay, so this one is the sample mean value x bar. When x bar is less than 21.371 or x bar is greater than 22.129 to mark out my critical region. Okay, so from sample, okay, x bar just now was 22.14, and this one, right, is actually greater than this. So this tells me that my 22.14, okay, is actually over here in the rejection region. Okay, and because of this, I will still get the same conclusion. Okay, so the presentation, right, is going to be like that lah, for the whole question, for question 3 part B, like that. Okay, so from here you can go this track, from here you can go this track, or you can go this track. Okay, either one. Okay, and technically speaking, you actually don't need to draw the graph. The graph is just for visualization purposes. Technically speaking, you can just write these two lines can already end by that. Okay, same thing. For the critical region, it would be nice to write out the critical region. Then you can write all this and like that. You can also write this and this at the end of the day. Okay, so one more time. This is to set up. This one over here is to test. So from step 5 to step 7. Okay, so I'll just leave this here, okay, for you to take in, and we're going to move to the next question after this. So let's continue with review exercise 4. So let's take a look at this question. In a large-scale community service project, a large group of 11-year-old perform a particular task. The officer in charge claims that average time taken is at most 50 minutes. So the claim is here, right? So this is the claim where the average time taken to complete the task, right, is at most 15 minutes, right? Now, so from this statement over here, okay, we see that the average time, the mean, would be at most 15 minutes, okay? At most meaning equal or less, right? The time taken by random sample is 75. So we have 75 11-year-olds over here, right? So this is our N. To complete the task is measured, denoting the time taken by T minutes. The results are summarized as follows. So we have a list of summarized results over here, right? So this one over here, right, is for us to calculate the sample mean. Okay, whereas for this one over here, right, is for us to calculate the unbiased estimate of the population variance, right? Because if you notice, right, we did not have any variance in the question, right? So we will be using this one over here as our population variance, right? Whereas for the sample mean, right, the sample mean is for us to test. So the thing over here is that we do not use this sample mean, or we do not use the unbiased estimate of the population mean for the distribution, because we're going to assume that the distribution would follow this mean, population mean in the question. Okay, so let us attempt part 1, which is to find the unbiased estimate of the population mean and the population variance, in which the formula can be found in MF27, and when we calculate, right, this is our results. Okay, so take note that when we do our unbiased estimate of population mean, because this one is a shifted data, so if we minus 15, we need to add back our 15 over here. All right, then the unbiased estimate of population variance, this one, because they give us the difference from the mean, so we're going to use the other form of the MF27, and we can cancel the n, so it's just 2025 over 74. Okay, so this is for part 1. Part 2, so now we're going to test at the 1% level. So 1% level refers to our significance level, whether the officer in charge is justified in the claim. Okay, so because this is a testing process, we're going to do all our 7 steps as usual. Okay, so step 1, declaring our random variable. Okay, something like this over here, and mu, right, to be the population mean of random variable x. Okay, so now over here, right, we are going to write down our null hypothesis and alternative hypothesis in step 2. So now the one that we got over here, right, now, so this one over here has the equal sign, right? So usually the quantity that has the equal sign would form our null hypothesis. So technically speaking, we are testing for mu less than 15, less than or equal to 15, right? Or in our syllabus, right, it is sufficient for us to just put equal to 15, because we are going to test on the other side, right? So technically we can put equal to 15. Okay, so even though the one in the question gives us this, right, we can also make use of this. Okay, just simplify to an equal sign over here, because we just need to test whether is it away from 15 or not. Okay, and this one over here is the officer's claim. okay, in which I will support or reject. Okay, then the null hypothesis will be the opposite of this, which is more than 15. Okay, so this is our step 2. Okay, in the next step, we'll set up our test statistic. So in the test statistic, we need because we are testing for sample mean, so we are going to get the distribution of the sample mean. And we will need our x bar, but the problem is for the x bar to be normally distributed, right? There's no mention that the x itself is normally distributed, right? So we need to tap on our central limit theorem to help us to set up our x bar. So it goes like this. Okay, so our test statistic is, we're going to assume that h naught is true, so it means we're going to use this. Okay, since okay, our sample size is 75 and is greater than 30, and this sample size is large enough by the central limit theorem. Okay, our x bar will follow a normal distribution. Now, under h naught, meaning we're going to take this population mean. So this one over here would be mu would be equals to 15. Okay, and because we don't have our population variance, we're going to take the estimate of our population variance over here, which is 2025 divided by 74. This is the variance divided by n, which is 75. Okay, approximately. Okay, so this is our distribution of x bar. Okay, so one more step further is that if you are going to do standardization, then your standardization will look something like this. Okay, so the z would be x bar minus the mean over your standard deviation. This distribution follows a normal distribution with mean 0 and variance 1. So this is our standard normal distribution. Okay, now we are going to state our next step, which is step 4. We are going to state the test, and we're going to state our significance level. For the test, we look at our alternative hypothesis to figure out which test we use. Greater than 15 means we're going to do a one-tail test to the right. So stating our tests, okay, and now we're going to proceed on with our 3 methods as to show you how does it work. Okay, so it will look something so I'll proceed on with 3 different methods from here. Okay, so I'll start off with the p-value method first. So p-value method, because we're testing at 1% significance level, so this tells me, and this is at the right hand side, right? So this tells me that this area on the right hand side has a probability of 0.011%. Okay, so the p-value method that we're looking for over here, we're going to see how to get this using our calculator. Okay, so with this, we can go to statistics, we can go to our tests, look for z-test, input our data in statistics. Okay, now hypothesis, the population variance would be 15 as seen in our question. Standard deviation is actually over here. Okay, this is the original standard deviation. So sorry, this original variance. So I need to put the square root for the standard deviation, 2024 divided by 74. Okay, so this is the standard deviation. X bar calculated to be, oh yes, from our sample we need to calculate our x bar. So yes, okay, so from sample, our x bar, or calculated above, so this is actually 16.2, right? So I'm going to put in my 16.2 over here. Okay, n is actually 75. Okay, this is a more than test, so I'm going to put in here and I'm going to calculate. Okay, so here we can see that the p value is 0.02. So from GC, 235. Okay, and this is more than 0.01, which tells me that the area over here, right, is more than the area shaded. Okay, so this area over here is 0.0235. And this tells me that this data over here lies outside the rejection region. Okay, so this data over here, okay, lies outside the rejection region, and because of that, the decision that we'll make from this test, right, over here is that we do not reject our null hypothesis. Okay, and the conclusion is that what is the officer's claim? The officer's claim is the null hypothesis, right? Means the officer's claim is there's not enough evidence to reject the officer's claim. Okay, something like that. Okay, so I'm going to write the statement out like this. Okay, so the sample mean 16.2, right, is not significantly far away enough from the 15 minutes, right, based on our 1% significance level. Okay, so this is the p-value method, really short. So technically you don't even need the graph, right? You just need these two lines and these two final statements. Okay, so that's for p-value method, right? The graph is just there to illustrate to you whether do we reject or not. Okay, and yeah, so this one over here would be like that. Okay, now let's take a look at the other method, which is our critical value method. And if we're using critical value method, right, we should be stating our rejection region. Okay, sorry, critical region. Okay, so for the z-score, right, the z-score over here would be 0, right? The mean over here would be 0, right? And we are going to look for this number first, right? This number over here based on the z-score. And how do we do so? We will do our inverse normal. So knowing our probability of 0.01, we're going to use inverse normal to determine what is the value over there. So the area is 1% or 0.1. Standard normal distribution under z is 0 and 1. We are going to take the area on the right and let's paste this. We calculate this to be 2.32, 2.33. Okay, if you want to be a bit more exact, 2.326. So reject H naught when the Z, okay, is greater than 2.326. Okay, or Z calculate. Okay, can now from the sample, okay, our X bar was 16.2. Now then from GC, right, now you can calculate this manually using our normal CDF, or if you go back to the statistics, right, under the Z test that we've done earlier, right, you can take the same steps and do the calculation, right? They give you the Z score over here, 1.98. So sorry, the Z calculate over here is 1.99. Okay, 9866. Right? So this tells me that the 1.99 is actually over here before our 2.32. Okay, so this value 1.99 is over here before 2.32. So the value lies outside the rejection region, and because of that, we do not reject H naught and there's not enough evidence and so on. Okay, now for the third method for completion, okay, same thing, we can establish our critical region. Okay, and how do we get our critical region? Would be inverse normal also, right? So knowing that this is 1%, 0.01, the value over here is 15, the mean is 15. What is this value over here? This is the what we're trying to uncover, right? So the area is 1%, but the mean now is 15. The standard deviation, right, is actually based on this standard deviation, this variance over here, right? So I'm going to put in square root of 2025 divided by 74 divided by 75. Okay, so this is a right tail test. So I will get 16.4. Okay, so this value over here is 16.4. Okay, when X bar is exceeding 16.4. Okay, 0, 5 and so on. right? So from the sample, we've calculated that our x bar is actually 16.2, which is less than 16.4. Okay, or the other one, sorry. This one is less than 2.33. Okay, we need to make the comparison. Okay, and based on this comparison, we do not reject H naught and it is over here. So means to say that our 16.2, right, is actually over here. Okay, before our 16.4, right? And because it lies outside the rejection region, we do not reject H naught and we follow the same conclusion. Okay, so this is the process to test our to carry out our hypothesis testing. Okay, it looks very long, okay, but yeah, so this is the process that we're going to take. Okay, we'll continue on with part 3. Part 3 asks us to state what is the meaning of the p-value in this context, right? So what is the p-value? The p-value is actually over here, 0.0235, right? So if you've done the p-value method, then you can calculate this and answer accordingly. So this 2%, right, refers to the 2% of the time taken, right, after this value. Okay, 2% of the time taken after this value. Okay, so it will be good if you can do a little bit of math, right? And you can try to find out that this value over here is actually 16.2, right? So if you were to put 15, right, your 16.2 is over here. Okay, and this is based on x bar. Okay, so means to say that there will be a 2.35% chance of the time taken to be above 16.2 seconds. Okay, so we just phrase it in terms of the probability, right? So p-value refers to the probability, so we'll just phrase it as the probability. Okay, so we are going to write it like that. Okay, so now the p-value and then means that if population mean is equals to 15, then there is a 2% chance for a sample size of 75 to have a sample mean of 16.2 or more, right? So it represents the probability of obtaining a test statistic at least as this. Okay, can so is that yeah, so this is what the p-value would mean, and this is how we should be phrasing the p-value nicely. Okay, now then for part 4, once again, explain what is meant by 1% level of significance in this context, right? So the 1% significance, right, refers to this area over here, this 1%, right? So this tells us that this 1%, right, is that there's a 1% risk of rejecting the null hypothesis. Okay, so we are willing to accept a 1% chance of 1% error, right? That the sample mean is actually over here, right? So we should frame this 1% significance level, right, in terms of the decision making process. Okay, so I will write it out as and phrase it as such. Okay, so the phrasing is such, it means that there's a 1% chance to conclude that the officer in charge is not justified in his claim when the time is at most 15 minutes, right? So the thing is that the 1% chance, the significance level is a 1% chance to reject our null hypothesis, right? So this is the process that we did earlier, and we will just need to replace or to explain what does rejecting the null hypothesis means. So it is to say that the officer in charge is not justified in his claim. Okay, so it's just mainly just to replace what this is. Okay, hopefully this gives you a much easier way to explain what is p-value and significance level. Okay, so with this, we have come to the second variation of question where we need to make use of the central limit theorem, okay, because the population is not defined for us, right? And because of that, we will continue in the next video to talk about the reverse problem. Okay, so we'll stop the video here and I'll see you in the next video.